Hello. Today we are going to talk about the different types of numbers. In order to move on to more complex ideas, we first must have a solid understanding of the basic sets of numbers. After today's lesson, you should be able to determine what category a certain number falls in. We are going to look at 6 different types of numbers. We will look at the following: natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. You will gain an understanding of the relationships between the different types. I have the numbers in this order for a certain reason, which will become clear in a few minutes. First, we will look at natural numbers. Natural numbers are numbers that you basically count with. That would be 1, 2, 3, 4, 5, and so on. They go the whole way to infinity, which means that there is no end to the amount of natural numbers, as there will always be another number we could add onto it. We use the capital letter N to represent natural numbers. Next, we are going to look at whole numbers. Whole numbers include all of the natural numbers and also includes the number 0. So we have 0, 1, 2, 3, all the way up to infinity. We can say that if a number is a natural number, it is also a whole number. However, we cannot say that all whole numbers are natural numbers because 0 is not included in natural numbers. Moving on, we are now going to look at integers. We will once again build on the previous types of numbers. Integers include all whole numbers and also include all negative natural numbers. So we have -3, -2, -1, 0, 1, 2, 3, and we can go on forever in both directions, leading to negative and positive infinity. We use the capital letter Z to represent integers. Now we are going to examine rational numbers. If you look at the word rational, we can see that it includes the word ratio. So rational numbers can be represented as the ratio of two integers. For example, any integer is a rational number, as 1 can be represented as 1/1 or 10/10. There are infinitely many ways to represent 1 as a ratio of integers. We could also represent -4 as -4/1 or -8/2. Once again, we could go on and on and on. So -4 can be represented as the ratio of two integers, making it rational. Now we're going to look at numbers that are not integers. So let's look at 5.25. We can still represent this number as the ratio of two integers, which would be 525/100. Or we would look at it as 5 1/4, which we would then turn it into an improper fraction, 21/4. Once again, a ratio of integers. We also have to look at decimals that are repeating. So if we have 0.3 and the 3 is repeating, we can represent it as 1/3 or a ratio of integers. Therefore, we can turn any decimal that repeats into a rational number. Thus, we covered finite decimals and repeating decimals, but we still have decimals that go on and on forever, that do not repeat, which leads us to irrational numbers. But first, rational numbers are represented with the capital letter Q, and it should be noted that all natural numbers, whole numbers, and integers are rational numbers. Here are some of the more common irrational numbers. You will use pi and e in many future math classes. They both go on forever and never repeat, making them irrational numbers. The square root of 2 is also irrational, as once again it goes on forever and does not repeat. Be careful not to assume that all square roots are irrational. For example, the square root of 9 would be simplified to 3, making it rational. So only the square root of non-perfect squares may be irrational as long as they do not repeat. Irrational numbers are represented with a capital letter P. Lastly, we have real numbers. Real numbers are numbers that are either rational or irrational. So everything we have covered so far are real numbers. Eventually, you will be introduced to imaginary numbers. but today we are just focusing on real numbers. Real numbers are represented with a capital letter R. Now we are going to look at some examples. So we are going to look at two numbers, and we will list the sets of numbers in which the number represents. First, let's look at 2/3. 2/3 is a ratio of integers, so it is rational. And since it is rational, it is also a real number. Next, let's look at 23. It is a natural number since it is a counting number, and since it is a natural number, it is also a whole number. And since it is a whole number, it is also an integer. And anything that is all three, natural, whole, and an integer, is also a rational number. We could write 23 as 23 over 1 to prove that it is a rational number. And since it is rational, it is also a real number. That's it for today. Next, you are going to click on a link and take a quiz on the material just covered. Feel free to use any notes that you took during the video. You need to have a score of 6 out of 7 to move on to the next assignment. Good luck and have a good day.